This is pre-planning and fire suppression of buildings under construction. That would be NFPA 1620 pre-planning. We're talking about pre-planning that the fire service is responsible for conducting. This would be in the event of an incident. This is an ICC preferred provider course, and you can, when you self-report on this course, for CEUs, you would simply look up course BCD 232. My name is Ray Obrocki. I am the manager of fire service relations for the American Wood Council. A little background on me. Before coming to the Wood Council, I spent 23 years in the Baltimore City Fire Department. I retired as the assistant fire chief, and I also served as the fire marshal for Baltimore City. After that, I retired and I went to the city of Rockville, Maryland, which is a little city right outside of Washington, D.C., where I was the chief building official. I say that not just so you would know who I am and who's presenting, but also to let you know that I have a background as a fire official and as a building official, and that's going to be important when it comes to certain concepts we're going to talk about today. So this is an AIA course, approved course, if you want to get those continuing ed credits. Today, this program is designed to provide background and information to fire departments that may experience the construction of a large area building in their community. Many fire departments have limited experience in the planning and response to these complex buildings. This requires a thorough understanding of the fire and building codes provisions, as well as proper use of NFPA 241, that's the standard for safeguarding construction, NFPA 1620, which is the standard for pre-incident planning. So our learning objectives today, we're going to go through and identify the risks and hazards on construction sites. We're going to learn the leading causes of fires in structures under construction. We are going to review model codes and apply them that pertain to safety precautions during construction and pre-incident planning. We're going to talk about pre-incident planning. We're going to identify the procedures and methods of pre-incident planning, and this occurs from the moment the building is in the design stage. And lastly, we're going to talk about tactics and strategies in the unfortunate event that there is an incident on a construction site of a large area building. We're going to talk about the firefighting, fire suppression considerations during these events. But I would like to plug the Construction Fire Safety Coalition. As you can see, it is free to qualified officials. We have fire safety manuals on here, links and resources, webinars. One of the more important things on this site, and if I have time, I will open the site later on, is checklists and guidance documents. If you wanted to start a construction fire safety program in your jurisdiction, if you're a fire service or building official, you would go there. We have NFPA 241 checklist. We have sample fire safety plans. We have sample policies and procedures surrounding hot work and other things. We have best practice documents. It's really a one-stop shop for construction fire safety. This is the nature of the fire problem in the U.S. This is from an NFPA report that came out last April in 2017. You can see the numbers there. They break it out under three different subjects. That would be buildings under construction, which amounts to a new project. And we average around 3,750 of those fires a year. The second category is buildings under major renovations. Those would be buildings that would be being gutted out and remodeled totally. We're not talking about a little tenant fit out. And they amount for 2,560 fires a year, and then 2,130 fires occur while a project is under demolition. I'd just like to review some significant fires that got a lot of press over the past several years. This is one that's fairly recent. It's in Denver, Colorado. This occurred March 7th, 2018. It was unusual for a couple of reasons. One, two people died in it, two workers died in it, and you rarely see worker deaths or major injuries on projects that catch fire. On construction sites, the fatal four are electrocution, falls from height, being struck by falling objects, and being caught in between things. They're the fatal four. They account for most construction fire deaths and serious injuries. Explosions and burns and fire account for less than 2%. The fire occurred in the middle of the afternoon. This was also very unusual. Most of these fires start small in the middle of the night, off hours, and grow. This one was, it happened very quickly during the day. It was a very hot fire. It caught 6 exposure fires, 6 roofs on fire that were surrounding this building. The incident commander did a very good job of protecting the exposures, and it still set 6 roofs on fire. It was a 5-story wood frame on top of a masonry podium. It was slated to be an 80-unit multifamily residential property. The radiant heat melted 40 vehicles, including fire service vehicles, and that will lead to a topic we're going to talk about later about spotting the pumper and spotting the apparatus. It was of an undetermined cause. I actually physically was there and saw the fire, aftermath of the fire, and talked to the incident commander, and they have some ideas, but none to the exclusion of all others. They think it might have been an equipment malfunction or a fueling incident that caused it, but it was listed as undetermined. College Park, Maryland, April 24th, 2017, was a 7-story mixed-use residential retail. Once again, it was type 5 construction on top of a concrete podium. It's wood construction. Sprinkler system was installed but not operational. That's a recurring theme you're going to see in a lot of these construction fires, where the sprinkler system is actually installed and could have been working, but it wasn't operational for a couple different reasons. And this one, the water hadn't been tied into the property yet. University of Maryland College Park was closed, and a senior housing site was evacuated. It really disrupted this area. It really snarled traffic and just completely disrupted the city of College Park. It was $30 million in damage. The cause was accidental. They wound up demoing the top 5 floors down to the concrete podium. They had to get the podium recertified before they could start building again. In Waltham, Massachusetts, you had an apartment building under construction, a big one. It was 264 units in 5 buildings, and it completely depleted the Boston region's fire resources. It was 10 alarms. High winds affected the fire spread, and the fire chief up there said it was intentionally set. And that's another recurring theme that deals with the importance of site safety that we'll talk about, site security rather, that we'll talk about a little later. Oakland, California, July 7, 2017. They had a series of East Bay area fires that were, some were ruled arson. This was an undetermined cause. Waverly was a very big property downtown, 7 stories mixed use, 328,000 square feet, 196 units. This one was of particular concern because it had a construction crane on site. A lot of these occur later on in the construction process, so the construction cranes are gone by then. This one, it was there, and it was a concern of the fire service. 100 neighbors had to be evacuated. Boston, Massachusetts, the Trademark Building, 83-unit apartment building. Occupancy was due within 17 days. As you can see, it was 6 stories. The sprinkler status was operational but not turned on. I don't have any idea why they didn't turn it on. Could have been because of it wasn't tied into the fire alarm. They were afraid of a sprinkler head getting busted. I've heard that excuse before. It was in June, so I'm pretty sure they weren't worried about frozen pipes, but that is another concern I hear. They were testing the emergency generator, and the exhaust was too close to combustibles. So it is no surprise that construction sites can be an unsafe environment. You have a bunch of sources of ignition, as you see listed here: smoking materials, cooking, open flames, Electrical equipment, light fixtures, heat and sparks from grinding and cutting, and then arson. And in conjunction with these ignition sources, you have sources of fuel, combustible refuge and trash, building materials, flammable gases, which would be on site for propane, operating equipment, or welding gases, flammable liquids, and packing materials. So here are some of the leading causes. I was surprised by this. On new construction sites, cooking equipment, 27%. Then heating equipment and intentionally set fires are 13 apiece. And then it goes down from there, torch and burner, smoking materials, exposure fires. These would be fires that start outside the subject building and catch the subject building on fire. You know, it could be a vehicle parked too close to the building that catches fire. It could be a burn barrel outside, any number of exterior sources. Codes and standards that pertain to safety precautions during construction and pre-incident planning. These are the model codes that safeguard construction. You have NFPA 241, which is the standard for safeguarding construction, alteration, and demolition operations. Now, this standard has been around a long time, actually. Many people don't know it. There's a lot of NFPA standards, it's no wonder. It's only about 16 pages long. It's not a highly technical standard, but it is referenced in the IFC, Chapter 33, in NFPA 1, Chapter 16, and I don't believe it's mentioned in NFPA 1620. That's the standard for pre-incident planning. That's the standard that fire service members are going to use to actually plan for incidents that occur, but it's basically planning for incidents that occur once the building is occupied. But the planning process starts in the design stage. You're going to have a separate plan under 241, which is a fire safety plan during construction. So I don't want you to be confused by the two. Actions to be taken. Work closely with the developer from the outset of the project. You need to clarify the roles and focus on basic fire prevention precautions. The code requirements that must be enforced, the planning processes and enforcement practice in 241 and 1620 that must be monitored. The fire department must simultaneously prepare for an aggressive attack in the event of a fire, and they need to constantly monitor two things: fire department access and adequate water supply. You're going to hear recurring themes here: fire department access, water supply, early notification. Access, supply, and notification. They are the three sort of legs to the stool on whether you're going to lose a building or the fire department has a chance of suppressing the fire and saving the building. And the different roles the fire department plays. The fire department has two basic roles in dealing with fires in buildings under construction. The first role is carried out between the builder and the Fire Prevention Bureau or Fire Marshal's office during planning. The second role is carried out between the construction staff and the Fire Operations Division during construction. The model code provides that the private party who's responsible for the fire protection plan activity at the construction site shall develop and maintain an approved fire plan that includes an approved pre-incident plan in cooperation with the fire department. Now, local policies and procedures must inform this pre-incident planning. If you look at 1620, it is an outline for and a standard for a plan, but the local jurisdictions have to come up with a policy on their own and perhaps even documents on their own. The pre-incident plan should include, but not necessarily be limited to, fire department access points, fire extinguishers and initial attack equipment locations, any special provisions for firefighting activities. What am I talking about when I talk about special provisions? If you look at unusual or complex structures, for instance, when I was a code official in Prince George's County, Maryland, they were building a power plant, and the power plant had a switch yard. The switch yard, when energized, was not allowed to be entered when it was energized, but it had outbuildings within the switch yard. So we had to build in a plan for if they had an incident in the switch yard, we had to have a plan to get Pepco to shut down that switch yard so it could be safely entered and you could commence with firefighting duties. Now, shutting down the switch yard isn't like flipping a light switch. It's complex, and you have to be able to contact the right people because they need to reroute that electric elsewhere. So we have provisions in place for that. If you have, say, a place that stores hazmats or some place that may have limited access, you have to have special provisions built into your plan for those unusual circumstances. You want to know the disposition of all built-in fire protection measures. That would be standpipes, that would be firewalls, any kind of compartmentalization that takes place or supposed to take place. Where the firewalls are the openings protected? You want to know if the sprinkler system is up and running. You want to know if the stairwell is encapsulated. Any sort of passive or active fire protection measures. Emergency escape routes and stairs. While I don't see a lot of fire safety plans on construction sites, most jurisdictions have always required an emergency escape plan during construction because the escape routes change during construction as construction gets higher or bigger, or they get rid of temporary stairs or construction elevators. We want to note the hydrant positions, and they also change sometimes. Assembly point locations. Under that escape plan that should be built into the construction fire safety plan, they need to have rally points outside the building so they can account for other people. The worst thing that can happen is they can't account for other people, and then the fire service is forced to send members in to a burning building looking for people that may or may not be in there, and they can't take a defensive attack on the building because they need to send the guys inside to look for people, if that's even possible. You also want details of temporary accommodation and storage areas, including hazardous item storage locations, flammable liquids, gas cylinders, etc. The fire department should meet with the owner and developer before construction and discuss some issues. Fire department access to the construction site, sufficiency of the water supply to the site, reporting of emergencies, and built-in fire protection. Pre-construction meetings are a great time to lay the groundwork for a pre-fire plan. You need to discuss the timing of construction. The fire service needs to know when you're going to start. They should have at least a loose schedule of construction so they know when they go vertical, when they plan on topping out, when they're going to bring building combustible materials on site. Anticipated weather and its challenges, the shifting contents of the building, and fire safety measures taken. During a fire event should not be the first time the fire department talks with the building contractor. The fire inspector interface with the building inspector, and this is what I talked about, the interaction between the fire official and the building official, and why there seems to be a gap in responsibility here. Building inspectors are in the building almost daily. They have more access than any other municipal inspector, while fire inspectors only inspect periodically, if at all. There's a trend in the fire service where a lot of non-maintenance inspections, the inspections that occur during construction, let's say for fire pumps or hydro for a sprinkler system, they occur by the building department now with civilian inspectors, and fire inspectors are doing more of the annual maintenance inspections. And I don't mean property maintenance, I mean fire code. Are they maintaining the building according to the fire code? Fire inspectors should engage in an ongoing dialogue with building inspectors about potential fire risk. While building inspectors know a lot about construction codes and electrical hazards, they may be blind to housekeeping and trash buildup and potential ignition sources. That's not their focus. They are there to inspect construction. They're going to go in there, they're going to grab the approved plans, they're going to look at the as-built and make sure they match. They're not going to pay attention to oily rags in the corner. They're not going to pay attention to buildup of trash. They may not pay attention if building materials are blocking fire department access or vehicles are blocking hydrants. Don't assume that building inspectors are going to be inspecting for fire safety practices. And the other gap comes with the mindset. Building inspectors think, I'm here to inspect construction. The fire department worries about fire safety. The fire department says, well, wait a minute, we inspect buildings once they are occupied. Once the C of O is issued, we inspect it. The building department inspects during construction, and this is where the gap lies. Neither side thinks that it's their responsibility to inspect for fire safety during construction, and I think that's a big problem. Built-in fire protection. Many fire protection features will not be fully operational until the building is ready for occupancy. That's 100% true with the sprinkler system usually, and the fire alarm system. The fire department should be aware of the status of the various building systems that will be relied upon during suppression activities. Most important is the standpipe during construction. Knowing whether systems are in or out of service could be a key factor in the decision to mount an offensive or defensive fire attack. Early activation of the sprinkler system may help reduce fire loss. In the fire in College Park, this was doubly true because the standpipe system, they had an open valve in the stairwell. So when the fire department pumped the FDC, the fire department connection, they thought they were communicating water to upper floors of the building. What they're really doing is filling the stair tower with water. So they didn't know the disposition of it. They had to go in and actually backfeed it, and they lost precious time and then eventually lost the building. Operational planning. Fire department should identify the following before construction begins and monitor during construction: the number of fire hydrants and water sources and their location. So what would be water sources other than hydrants? Well, you can draft out of lakes, streams, retention ponds. There's possibility that you can't bring adequate water on site, so they have to mitigate that with a tanker. You also want to look at the types of the materials present and their storage method, additional resources to help with fire. You know, the example would be moving vehicles or protecting temporary structures like construction trailers. Identify who will notify the fire department when construction begins. That is important to make the fire department aware of how far along you are. The following information should be collected and shared. Contact person and phone number is very important. The first due company, and then verify the address is known to dispatch. Now, this is the issuing of addresses is a zoning and planning function, meaning a planning function. The planning department usually issues addresses. And sometimes these buildings are built on subdivided lots that sometimes don't have an address yet, or they have an address that's going to be changed. I worked on a very large casino where the address of the property changed 3 times. So we want to make sure that your fire department dispatch knows what the correct address is, so there's no delay in trying to find or confusion in trying to find this building. The CAD system, if it has a computer-aided dispatch system, should be updated as needed. Before work begins, other factors must be addressed. Do subcontractors have fire prevention plans as part of their processes? Do they have emergency response plan as part of their resources? And there's a lot of moving parts on a construction site. So, you know, there's a lot of entities there. There's the trade, the subcontractors, the GC, the owners, reps. So we want to make sure they're all on the same page. Now, a proper fire safety plan would address the following issues. Do they conduct training? Do they have a system of accountability for their workers in an emergency, which I talked about? Have they established a warning system? Is fire equipment available, which would be more than likely fire extinguishers? Do they have a hot work permit system? We're going to talk about this a little bit later. Very important. And it's also a bellwether to see how serious they are about safety. Are flashback arresters used? Are compressed gases on site and how are they stored? Is welding equipment inspected and in good shape? What personal protective equipment is in place? During construction, more elements to address: constant maintenance of fire protection equipment. Hydrants need to be visible and unobstructed. I had a building inspector that if he saw any construction materials or vehicle blocking a hydrant, he would issue a stop work order or threaten to issue a stop work order. Consequently, no one blocked the hydrants on his sites, but that he was kind of rare. He was a building inspector, but he had a fire service background. Hydrants are operational. Extinguishers are adequate and properly located. You want to make sure they're fully charged and tagged. The standpipe has to go up with the building. That's not a recommendation. That's actually a code I'll talk about a little bit later. The fire department connection needs to be visible, marked, and readily accessible. What does readily accessible mean? Well, that's the exact term out of the code, readily accessible. Is readily accessible mean behind a gate? We had a daycare center in the bottom floor of a multifamily mixed use, and it had a play area for kids that was fenced in, and the fence had a locked gate, and the FDC was inside that fence. The fire marshal said, no problem, just put a Knox box there with a key in it to the gate, and he thought that was fine. Other fire service folks might not think that is fine, but readily accessible is just an illustration of the discretion the code gives the fire official. You want to maintain clear access to buildings and onto the site. All roads must be kept clear of debris. You need an all-weather driving service. So is that crush and run? I think a lot of people would say yes. 20 feet of unobstructed width. And this is unobstructed width. We can't have 20 feet and then park vehicles there. So if you need to park vehicles along this access road, it has to be bigger than 20 feet. Turnarounds for dead end roads of 150 feet or more. So if you have a dead end road of 150 feet or more, you need to have a circle or a hammerhead. So an apparatus does not have to back 150 feet out to turn around. Access roads must extend to within 150 feet of the building. Why 150 feet? Well, I think it's changed nowadays, but traditionally, most companies had 3 sections of hose on their quick attack lines, and each section of hose was 50 feet. 3 sections, 150 feet gets you to the building. And you want at least 13.5 feet of vertical clearance. Access is very important, as I say, and we'll keep saying. You want to keep materials from accumulating around the building. Piles of wood or other combustibles should be kept away from the building as far as possible unless they are an active part of construction. You want 30 feet of clearance from construction materials to the building. Trash and debris removed daily. Construction materials not stored in the building unless fire protection is in service. So that 30 feet of clearance, when you hear about these clearances, these are best practices. You're not going to be able to gain that 30 feet of clearance in a city setting. You're just not going to have that kind of setback or that kind of yard space most of the time. So that's why building and fire officials have to get together with builders and general contractors to determine what mitigation measures they need to take to protect that construction material if it's closer than 30 feet. Maintain a no smoking policy in or near the building. Set up a designated smoking area for employees off-site. Monitor the no smoking policy by conducting audits. If a smoking area is set up on site, make sure it's covered against inclement weather so employees aren't tempted to go into the building to escape the weather and smoke. Make sure it's located away from any construction and combustible material and that proper receptacles are present for disposal. Some construction sites ban smoking totally. I think there's 2 schools of thought here. One school of thought is you ban it totally and that's it. Another school of thought is, well, if we set up a designated area and we protect that area adequately, then we can control the smoking and can control the negative effects that smoking could cause. I come down in the school of thought that smokers, and I apologize to any smokers listening, can be relentless. They will find a way to smoke. And I'd rather have them smoking in a designated area with the proper receptacles than sneaking in buildings that are under construction and smoking, because they usually smoke in an area that is hidden away and usually dispose of their cigarette butts in areas they won't be discovered, like openings in construction and open shafts. And that's also the place where people throw trash. So it can be a big hazard. Hot work / burn permits should be used. This would be a pre-inspection of the work area. So these hot work burn permits aren't permits issued by governmental agencies. These are internal to the construction site. Now, having said that, Massachusetts does have, and Boston and I believe Salisbury and Worcester started out issuing hot work permits. You had to go to the city or the governmental agency to get those, and they monitored those. But generally around the country, it is an internal process that's set up by the GC or the developer. And the purpose is so they can control where and when these hot work occurs. This would say, I would petition the person issuing the permit on site, I want to do hot work in this certain area. So it would be a very specific area. Say it would be building 1, floor 2, stairwell B. And the hot work will be welding a staircase or the railings. The person issuing the hot work would go out and inspect the area prior to the hot work to make sure all the combustibles are removed. They would also make sure that there's a charged fire extinguishers at the point of work and that there's a dedicated fire watch at all time, and then monitor the area 30 minutes after the work is conducted with a fire extinguisher. It's a way to control the hot work. I want to talk a minute about fire flow. The determination of fire flow is a common function in fire prevention bureaus and building departments. The American Water Works Association publishes Manual N31, which is used to determine fire flow for an occupied structure. ISO has calculations for needed fire flow expressed in gallons per minute. It considers many factors: construction type, building size, and sprinklers. It also assumes that the structure is ready for occupancy. Calculating fire flows assumes that all fire mitigation factors are in place. Firewalls are there, fire doors are there, stair towers are intact. You have a fully operational standpipe, you have fully operational sprinkler systems. Fires during construction hit their peak heat production differently than for an occupied structure. That single factor alone may determine the effectiveness of an initial attack or the overall strategy. So there isn't any guidance for needed fire flow during construction. So heat production during fires, total heat release is the number of BTUs released when all of the fuel is consumed. The peak heat release is when BTUs are at its highest rate. Peak heat release rate is a key factor related to exposure fires. Neighboring buildings are most at risk during this peak release rate. Construction fires and occupied structure fires have the same total heat release, but have two vastly different peak heat release rates. And for construction fires, they can be totally unpredictable. Like the fire in Denver, the incident commander told me that the fire intensity went from, let's say, a 10 to a 90 in about a minute, and she surmised that the fire hit a fuel source, either fuel gases or flammable liquid somewhere inside. It was never proven, but it got so intense so quickly. That was her educated guess. Determining the risks. This is the Canadian approach. There was a study and a paper written by Chief Len Garris of the Surrey Fire Department, among others. And it was written by the university, it was published by the University of the Fraser Valleys. And it's called Construction Site Fire Response, Preventing and Suppression of Fires During Construction of Large Buildings. So they list 3 levels of risk, or they rate 3 levels of risk management: minimum, moderate, and high. Depending on the category the project falls within, it will inform the fire department's role and level of involvement based on the category. Minimal risk, small projects, single family homes, townhomes, they are probably the lowest level risk because it's they've rated it minimal. It's a small building, small project, probably an infill project. Rarely fenced, limited security, maybe when plumbing or rough wiring is in. Limited firefighting and control capabilities on site. You're not going to have a standpipe. You may have an extinguisher, maybe, and there's minimal to no emergency planning for a site like this. The moderate risk level is going to be your most common for the projects we're talking about. Mid-rise condo projects with 100+ units. That's going to be up in Canada. That's going to be fenced from the start. You're going to provide security evenings and weekends. Hot work permit system and trained safety officers are going to be in place. Roughed in fire protection devices installed after floor above is complete. Any building occupied while construction is occurring has fire sprinklers and fire alarm working. That deals with the phased occupancy aspect. People that own buildings, build buildings, many times want to get rent started, so they will build it in wings. So there might be 3 wings to a project, and wing A is ready to go while they're still operating on wing B and C. So they want to have temporary occupancy of, say, wing A. Or in a high rise, they might want to occupy floor 1 through 7. So there has to be a plan in place, and the fire protection measures need to be fully functional before you can have occupancy in a building that is not completely finished. The highest level risk, larger risk managed projects such as hospitals, schools, government buildings. These are structures that really impact the community. Many are publicly funded. So that on these projects, we're talking providing project managers and site fire protection. You want a hot work system in place. Just in time materials delivery. This means you're going to bring in material and you're going to use it right away. You don't need all, let's say, plywood. You don't need all the plywood for a job delivered on day 1. You get it delivered as you install things. They require an on-site project engineer, site security from the start of the project, 24 hours a day, 7 days a week. Trades are not permitted on site when project manager and safety officer are not present to supervise them. Fire and detection systems are installed as the building is constructed. Partial occupancy is usually not allowed until completion, so there would be no phased occupancy or temporary occupancy on these structures. Now we're going to talk about the pre-incident plan, NFPA 1620. This document is not intended for pre-incident planning related to construction, alteration, and demolition. That is what NFPA 241 talks about, a construction fire safety plan. But right out of section 418 of 1620, it says the development of a pre-incident plan for new facilities and other situations shall begin during the design phase. So there are pre-incident planning functions that can and should occur from the time a building is designed. What is pre-incident planning from an operations perspective? It is a process for gathering and documenting information that is critical for making incident command decisions on the scene. NFPA 1620 provides the criteria for developing pre-incident plans for use by emergency personnel. Local fire departments can, and mostly do, create their own version of pre-planning forms. However, in the appendix of 1620, they do have template and sample forms that you can pull from. The objective is to map out a common understanding of the facts, probabilities, and possibilities of what could occur on a specific site. A quick overview: the AHJ shall determine the locations to be pre-planned and the data to be collected. Your fire department needs a clearly defined policy and scope. Are you going to pre-plan the corner store? Well, if you're in Baltimore City, you probably don't have the personnel to do a corner store. Are you going to pre-plan a hospital? Absolutely. You're going to pre-plan a mixed-use multifamily building? Most likely. So the capabilities of your fire department, we're going to dictate what you plan, which buildings you pre-incident plan. The more the merrier, I would say. The process is a cooperative process among the pre-incident plan developer, the facilities management, and the responding personnel. The following items should be considered: potential life safety hazards, including first responder safety, structure size and complexity, economic impact to the community, importance to the community, location, and seasonal variations. What do I mean by that? Well, in Ocean City, Maryland, a hotel in February is going to be much less occupied than a hotel in July. That's when we talk about seasonal variations. Presence of hazardous materials and processes, susceptibility to natural disasters. Electronic plans are allowed if all 4 conditions are met. You have to meet all 4, not 2 of the 4, not 1 of the 4, but all 4. The electronic connection is considered reliable by the AHJ. The electronic connection is secured against unauthorized users. The electronic version is available at the incident scene. That's important. They're not going to do anyone any good sitting on a desktop computer back at fire headquarters. The incident commander needs to see the information, see the plan on the scene. The electronic version is protected from unauthorized changes. Physical and site considerations. Construction type, building management systems and utilities, external site conditions, internal and external security features, fences or other barriers. Life safety considerations, hours of operation, occupant load, occupant accountability, assistance for non-ambulatory occupants, non-evacuation strategies for protecting occupants or shelter in place. We also call those areas of refuge. Water supply and fire protection systems. I'm going to beat this drum the whole day. Water supply and access issues. You want to know your available water supply. That would be your mains, your hydrants, the static water sources that I talked about earlier, the ponds, the streams, the retention ponds, where you could possibly draft from. The fire pump room is very important to know where that's located. FTC locations, and I had already mentioned about what does readily accessible mean. Non-water-based protection systems, which would be like an FM200 system or an ANSL system for a hood in a commercial kitchen. And fire alarm control unit location. We're going to look at hazardous materials, type of hazmats on location. We want to know the inventory, we want to know the location, and if any special extinguishing agents are needed and where they're located, because the fire department, they're not going to carry around every agent that's used to extinguish a special chemical. They're going to carry foam, usually probably 2 5-gallon cans that'll last a couple of minutes, and water. And they need to know the location of the material safety data sheets. And that's required by law, that if you have a certain inventory of hazmat, you have to have an MSDS for every single type of hazmat. Vacant and abandoned structures. I would say that most fire service personnel that I know wouldn't think that they need to pre-fire plan a vacant or abandoned structure. Nobody's in there. Why should we plan that structure? I believe these structures need to be planned more than any of the structures because there's so many unknowns. One thing that is important is the last known type of occupancy. That's important because it may inform you to what hazards might be inside. There may be hazmats that are left behind. You could have open shafts. When these buildings are abandoned, many times the people who own them scrap out a lot of the things, the elevator equipment and stuff like that, and it will leave open shafts. They might take the metal and scrap it, or people might come and cannibalize the place. Pits and holes due to removed equipment, structural degradation due to weather and vandalism. If you have an abandoned building, you're not going to make sure that the roof is watertight. You're not going to make sure that it has good storm windows on it. So these things are left to disrepair. Water gets in, moisture gets in, and you have structural degradation of floor joists and construction of all types. Exposed structural members, penetrations and barriers that allow abnormal fire travel. You're not going to have fire doors in place. It's not going to be compartmentalized. You're going to see openings in construction that will allow fire to pass through what used to be firewalls. Combustible contents, some of these abandoned places make good dumping grounds for illegal dumping. So folks go and they dump their stuff in there. Maze-like configurations. We had some in Baltimore City where you had abandoned warehouses that artists and artsy type people went into and became squatters, and they set up these petition walls and had sort of these illegal live work units. There was one in Oakland, I believe, a couple years ago that caught fire and several people died. You have blocked and or damaged stairwells. You cannot count on the normal building systems to convey you to the top floors. You have stairs that crumble, people remove things, damage things. So you may have to reach the upper floors by ladder. It may be the safest way. But you need a pre-fire plan for a fire in a vacant place for exactly that reason. Potential delay in discovery of the fire, potential for multi-room fire on arrival, and exposure issues from nearby structures. Points of interest on a construction site plan: availability of fire protection systems, mitigation practices, once again, water supply, means of egress and access, and location of hazards. Very important. Once ignition occurs, a series of events that result in the fire department response and suppression activities become the #1 priority. So I want to talk a minute about fire department capacities. Fire service is not a monolith. Every fire department is different. Every jurisdiction, every fire department is as different as its jurisdiction. So we really can't have one overarching plan for all fire departments when responding to all construction site incidents. Every fire department has a capacity determined by its resources, so it is important to be aware of the strengths and the limitations of responding fire departments. But firefighters should be prepared to go big quickly. That means to generate as much fire flow as possible. Consider a 2.5-inch blitz line early on. Get master streams and aerial ops in place as soon as possible. As I stated, not all fire departments are the same. Some are staffed on a full-time basis and have multiple fire stations. Others are staffed with volunteers and have limited resources. So it's critical that the people who prepare these plans work with fire department to understand the level of fire service they can provide. Site supervisors, when developing the plan, should meet early with the Operations Bureau to establish criteria for several components of the plan, including vehicle access and water supply. Also to be discussed is whether the local department has the capacity to handle a fire on site and whether it will rely on outside resources to assist in controlling the fire. So these outside resources would be mutual aid. And there's a couple of types of mutual aid. Automatic aid, they're both agreements between communities where equipment will respond from outside the community to another community to help out. Automatic aid is set up automatically, as the name suggests. So when a box is struck out the computer-aided dispatch system will automatically dispatch neighboring jurisdiction apparatus without the incident commander requesting it. Mutual aid is the same thing, except it doesn't happen automatically. It takes a little longer because the incident commander has to get on site. He has to request it. That request has to be relayed to the leadership or the dispatch center of the neighboring jurisdiction, who then decides who they're going to send, and then they send them. So automatic aid is the ideal standard, but many jurisdictions don't have interoperability with their CAD system, so they couldn't do automatic aid if they wanted to. Mutual aid or automatic aid usually play a part in all large construction fires. There's no fire department that I know of that has the capacity to fight a very large fire and still cover their jurisdiction. Just because a fire is happening, a large fire is happening, doesn't mean that no other fires will happen at the same time. The fire service still has to cover the entire jurisdiction. Fire department should compare its capacity to the target hazards involved, and they should plan accordingly. So once ignition occurs, it's as unfortunate. You put your prevention measures in place, your best practices, and even the best intentions, the best laid plans of mice and men sometimes go awry. So once ignition occurs, the series of events that result in the fire department response and suppression activities become the #1 priority. So we're moving out of the prevention realm, out of the pre-planning realm, into fire suppression activities. So while fires on construction sites made up only 0.8% of all structure fires from 2010 to 2014, they get a disproportional amount of media coverage. The real fire problem in this country is 1 and 2 family dwellings. That's where the lion's share of the vast majority of structure fires occur. But they don't get the media coverage that the big construction fire gets on television and the print media and social media, the internet, because these fires are big. They disrupt large areas of town. Everyone knows there's going to be a major economic development impact hit when this occurs. They're telegenic. You know, you see a lot of fire and they get a lot of attention and they're sensational. So the media reaction is almost exclusively negative. And when these fires occur, sometimes there is a backlash or an overreaction in the community after the fact to want to roll back construction codes because of a single fire. Conforming to best practices to reduce the frequency and severity of these fires can reduce a considerable amount of criticism and heartache and work later on for everyone involved. Building materials and contents have changed drastically, but the basics of firefighting really hasn't. We still use water and hoses to suppress fires. We make decisions to enter a structure based on a series of factors: smoke color, flame spread, and experience. Our understanding of ventilation and the movement of hot air and gases has become more refined over the years. One of the jobs I had before I became fire marshal for Baltimore City was fire investigator. And during training as a fire investigator, they had 2 burn cells that were completely enclosed. One burn cell was going to be lit on fire with gasoline, the other burn cell just with the materials in the room, no accelerant. There was a person who wanted to go take a picture of the burn cell that had the natural, the non-accelerant start, just holding a candle in a couch, no gasoline. But they forgot to close the door when they left that compartment. And the fire in that compartment was a complete burnout compared to the fire where they actually used gasoline because of the introduction of ventilation. So hot air and movement of gases is a key factor in every type of fire. Tactics and strategies employed by fire departments vary considerably from community to community. There are standards for both staffing and the apparatus. There are many suggested guidelines. The ultimate choice on how a fire department chooses to fight a fire is based upon their knowledge and their policies and procedures. Every single fire department that I've ever been associated with or come across have an SOP or an MOP, a standard operating procedure or a manual procedure that deals with how they handle certain situations. And those documents are going to inform on how they're going to fight a large area building construction fire. As I've said, every fire department has different capabilities, so any specific talk of strategy and tactics would be meaningless without knowing the capacity of your individual department to deploy fire suppression resources. If I were sitting here saying, oh, you have to get 5 ladder trucks and master streams going within 10 minutes of the beginning of the fire, that would sound really good, but you may be in a jurisdiction that has 1 ladder truck and the next one is 15 to 20 miles away. The focus will be on a couple very straightforward observations about firefighting on construction sites. I like to call them considerations. As stated previously, the basic fire flow calculations are for a structure that is completed, it is occupied. A fire during construction will have a different demand because the various built-in fire protection systems may not be online, and I would say probably won't be online. It is advantageous to have multiple mains as your fire ground water source, possibly from 2 different streets. Now, this may be difficult in some jurisdictions. They don't have a really robust water system. Or if you are in a remote area of a city, the farther you go out from the center of the city, sometimes the water flow is diminished and the mains are diminished. So you might have to pull multiple fire hydrants that are all in the same main. That's not ideal because you're robbing Peter to pay Paul, but you have to do what you have to do. Charging the FDC as soon as possible is critical for making an interior attack. So you have to ask yourself, is the water supply adequate to suppress the fire? If not, can more water be brought to bear in a timely manner? Is there access to the building for an interior attack? If the answer to any of the above questions is no, it's time to take a defensive posture and protect the exposures. I brought up the Denver fire. Early on, the incident commander told me that she knew she did not have, the fire had gained too much headway before they got there. That building had no or very limited access on 3 sides. So she made a really smart decision to turn the majority of her master streams onto the buildings. And while they did have 6 roof fires, exposure fires on the roofs, they were on the surface of the roofs, they didn't lose any of the buildings surrounding that building. And when I say they were surrounded on 3 sides, some were as close as just 20 feet across a narrow alley, maybe 30 feet across a narrow alley. So she saved all those buildings around there by recognizing early on that she did not have the water supply to adequately suppress the fire. What does the code require with access and water supply? NFPA 241 and IFC Chapter 33 have water supply requirements for construction site. They do not include any fire flow calculations. It is absolutely left to the AHJ to come up with the fire flow. This is what NFPA says. It says there shall be a fire protection water supply, temporary or permanent, shall be available once combustible materials accumulate. When underground water main or hydrants are to be provided, they shall be installed, completed, and in service prior to the start of construction. This is what the IFC says. They say an approved water supply for fire protection shall be made available as soon as combustible materials arrive on the site. What is considered an approved water supply that meets the requirements of the IFC or NFPA 241? It's up to you. That's what it means. It means whatever you say to the builder, it means. There's absolutely no guidance on the subject. It is totally left to your discretion. I did find a local interpretation. Under this interpretation, the minimum fire flow required when the contractor brings combustible materials on site is 1,500 gallons per minute at 25 psi. At least one hydrant shall be within 500 feet of any combustible materials. Contractor is responsible for ensuring that the water supply is available at all times. How did they come up with 1,500 gallons a minute at 25 psi? I have no idea, and I suspect it's not grounded in any kind of science. And I'll give you a case study. When I was a building official in the city of Rockville, Maryland, there was a 149 unit 4-story construction fire. Montgomery County Fire Chief told me that his units were flowing as much as 5,000 gallons a minute. These are several aerial ladders flowing. As you can see from that picture, that's a picture of the fire. It actually started in an upper floor where, had the guard service actually been patrolling, they would have seen it and turned this generator. This generator was an arc fault in a portable heater that caught combustibles, trash and debris on fire that went into the roof. This was in the month of March. The sprinkler system was fully commissioned. It just wasn't turned on because it wasn't tied into the fire alarm. The building owner did not want to turn the system on because it was a very cold March. They were afraid of frozen pipes, and that if one busted because it wasn't tied into the fire alarm, nobody would know about it, especially it happened on the weekend. It would do tens of thousands of dollars worth of damage and water damage. So that's why they didn't turn it on. This fire did about $30 million worth of damage because all that construction had to be torn down to the podium. Back to my point, how many jurisdictions could generate 5,000 gallons a minute or 15,000 gallons a minute if you had 3 aerial ladders throwing this? If the water supply isn't available, operations must shift to exposure protection. Firefighting access exterior. You want to designate a suitable location as a command post provided with plans, emergency info, keys, and communications. Every building must be accessible by a road with an all-weather driving surface of at least 20 feet of unobstructed width. We talked about that. Dead-end roads of more than 100 feet must have a turnaround, and all access roads must be within 150 feet of exterior first-floor walls. Does this happen all the time? In College Park, you did not have that kind of access. In many of these construction fires, you have access from one side. That happens in site plan development. This is something that zoning and planning approves. That's out of the hands of the fire service. This is what we're supposed to have. We don't always get there. Firefighting access stairs provided at least one usable stairway at all times, extends upward as each floor is completed. The stairway must be lighted. Enclosed stairways once exterior walls are complete. So once you button up the building envelope, you can't have any exterior open stairways. You want to provide identification signs to include floor level, stair designation, and exit path directions. Good luck with that. I had a hard enough time getting that signage on a completed building. But all you need is one usable stairwell. If you look down in the picture, I've used this picture a couple times in this program. You have several stairwells that are going to be built. Hopefully they're all going up as the building going. I suspect they are, but they're only required to really have one. And that's a big Texas donut building. And you aren't going to have any real access if they only decide to construct one. Fortunately, most of these, the stairwell goes up as the building goes up just out of convenience. The standpipes have to be maintained in conformity with building progress and ready for use. At least one standpipe prior to construction exceeding 40 feet must be within one floor of the highest point of construction. That is a code. That's not a best practice. It must be conspicuously marked. I mean, the FTC has to be conspicuously marked and readily accessible with one hose outlet on each floor. Once again, look at my picture of the Texas donut, okay? Imagine if you only had one stairwell and you had one standpipe, or you had every stairwell, but only one standpipe is required, and it's in one corner, and the fire is in a completely opposite corner. How many sections of hose would it take to get over there? Or say it's in an interior fire and it's venting to that courtyard that has no access for vehicles in there. It's going to be a lot of problems. I see that the building code is eventually going to go to, you're going to have permanent or temporary standpipes in every usable stairwell where a permanent standpipe is eventually going to go. I do see that happening. I was in a construction fire safety roundtable in Los Angeles, and they are coming up with a robust policy for preventing construction fire safety, and they are kicking around the idea of requiring a temporary permanent standpipe in every usable stairwell. With water supply, do we have enough water supply to support an interior attack? Do we have adequate personnel to conduct an interior attack? Are the standpipes in service? Is the FTC readily accessible? Is it safe to conduct an interior attack? Do we have enough water to suppress the fire, or do we use the bulk of the water supply to cover the exposures? These are all questions that an incident commander is going to have to ask themselves very quickly, and they're going to have to make a choice very quickly. Some considerations when spotting the apparatus. Consider the higher radiant heat with construction fires. The difference we talked about between the total heat release rate and the peak heat release rate. Construction fires reach their peak much quicker than occupied, completed buildings. Do not spot apparatus in the collapse zone. Save room for aerial apparatus. As a general rule of thumb, when it comes to collapse zones, it's 2 times the height of the building. I've been told by other jurisdictions, and this isn't a code, this is a standard operating procedure. In Baltimore City, it was 2 times the height of the building. Some places build in a safety factor even above that. I've heard 2.5 times the height of the building. Now, if you were to add a construction crane to the mix, like in Oakland at the Waverly, that is going to be a big collapse zone. So these are considerations when spotting the apparatus. In Denver, they spotted too close, and there was damage actually done to their apparatus. The only injury that I heard of was a vehicle driver, a pump operator, had a metal appliance on the ground, and he went to pick it up when they had to move the apparatus back because their lenses were starting to melt on their sirens and their headlights. He grabs his metal apparatus without a glove, burns his hand because the radiant heat from that fire so superheated that metal appliance. And you don't want to jockey apparatus around. You're going to fight these fires with master streams, so make sure that the fire engines don't block out the fire trucks, and hopefully the police won't block everybody else out too. Inevitably, where there is a fire, there will be a fire investigation. Fire losses in large construction projects involve many interests: lenders, developers, owners, insurance companies, and some are publicly funded. These folks all have a lot of interest in these projects, so they're going to want answers. And most of these projects, if not all of these projects, will wind up in a court of law someday. The fire will always be investigated as a criminal act until proven otherwise. So documentation and collection of physical evidence at the scene is critically important. The incident commander needs to take note of all factors relevant to the origin and cause and protect the scene from any unnecessary activities that could destroy evidence. Now, does this mean that if you need to ventilate, you don't cut holes? Does this mean you don't pull ceilings? Does this mean, no, you have to do what you have to do to suppress the fire and protect the public. But you want to make sure that you don't go overboard and do unnecessary destruction to potential evidence. Spoliation of evidence is a big problem when it comes to trying to investigate a fire. NFPA 921 is the guide for fire and explosion investigations, and it talks a lot more about the protection and preservation of evidence. So firefighter safety is paramount to everything that we've talked about. Everything that I've discussed today deals with protecting those folks who have to go in or have to fight and suppress these fires. The National Fallen Firefighter Foundation supports the decision that firefighters do not enter buildings in which life safety is not an issue. That is why it is important that in the plan, they have an accountability procedure for their own personnel. They have staging areas and rally areas, and they have people that take head counts, and they can say with confidence to the fire service, everybody's out, because that will make a decision on whether you have an offensive or defensive attack on this fire. If it is verified that the structure is under construction is not occupied, defensive firefighting simply makes more sense. Access for firefighting is an extremely important consideration. You have to consider an adequate collapse zone and a suitable location for incident command. You don't want to be in the middle of a fire and have the incident commander be in jeopardy, because the incident commander is going to be the linchpin of communication. Everybody communicates through the incident command system. And the most important consideration is that everyone goes home, which is also the motto of the National Fallen Firefighters Foundation. But in the middle of an incident, you don't want the incident commander wasting time moving back. They need to set up and stage and stay there for the duration of their involvement in that incident. So the conclusion is everyone goes home. So what did we learn? We learned strategy and tactics. We reviewed fire prevention strategies and firefighting operational tactics in the event of a fire. We've reviewed safeguards during construction codes, which are contained in NFPA 241, International Fire Code Chapter 33, NFPA 1 Chapter 16, and NFPA 1620, the pre-planning standard. We discussed firefighter safety considerations, access, water supply, spotting apparatus, the decision whether to take an offensive or defensive attack on the fire. And lastly, we went through the components of a well-prepared fire safety plan. We talked about the construction fire safety plan, and we talked about the pre-incident plan that is going to last the life of the building. And these are living documents that change as the building changes, and they should be updating. It's not a one-time deal where you pre-plan and that's the way it stays. You want to hopefully visit these places, these target hazards that you've elected to pre-plan once a year. If you can't maintain that schedule, once every 2 years max. So these are the considerations, the strategy and tactics, and the codes and standards. And now I'm going to turn it over to questions.
Okay, thanks, Ray. Very well done. And I'll remind folks, Ray, maybe you can pull up the Construction Fire Safety website while I remind folks of a couple of things. One, you'll want to stick around through this Q&A for the next 15 minutes to get your hour-and-a-half credit. So if you're looking for an hour and a half, you got to meet that minimum threshold, and the Q&A is part of that. So stick around. And also, now's a good time to start asking some questions if you had some that came up along the way, and we'll spend the next 15 minutes doing that. But Ray, why don't you first, you alluded to this Construction Fire Safety website, give folks an overview of what's there and what kind of resources they can find.
Okay, for our fire service folks that are listening, we have a special tab just for fire service resources. And what that does is we have a bunch of templates, and the templates are for a model fire watch policy. And if you notice, we have it in PDF and we also have it in Word. That way you could take our model fire watch policy, you can manipulate it for your local needs, You could put your own logo on it. We have a model fire plan checklist for folks that want to use have their inspectors work off a checklist, or even their line firefighters work off a checklist. This would be important because I know when I was the fire marshal of a jurisdiction, I did not have the personnel that could go out and do construction site inspections as well as their annual permit inspections. So with this, you could go in and it says, what are the contents of an effective fire safety plan? So you could have a line fire service person look at the fire safety plan, and it's a checkoff box of all the things that are included or should be included in a good fire safety plan. And that's just one resource there. We also have, for developers and architects, we have briefings for employees. The Cambridge Fire Department has a construction site checklist that's very good as well. You could, and that's more towards inspectors actually on site. Let me go back, because there's fire safety manuals, and we have, this is an interesting one. It's occupancy of buildings under construction guidance document. So this is a policy out of Alberta, Canada. We have it in Word and we have it in PDF that outlines what you have to do to have what they call phased occupancy. That's always a question. People want to start using the portions of the building that they can use or they think they can use while other construction is still going on. It's a big issue in a lot of areas that are hot on the, I'll pull up the PDF version. And this document is the purpose of the document, and we look at all the things and the criteria that have to be met to get phased occupancy out of Alberta, Canada. I think it's a good one, but it doesn't have to be, cut and paste to your jurisdiction. You can have more requirements, hopefully not less requirements. Now, also, we have sort of a one-stop shop down here in our fire safety toolkit that we put out Fire Prevention Week, and that is in Word. And this is for some jurisdiction that might want to start their own construction fire safety program. And this is in Word, so you can manipulate it. And you have a NFPA 241 checklist that is based off of all the requirements of 241. I can scroll down and show it a little bit later. And that is what Montgomery County, Maryland uses, and they actually take it so seriously, they staple this checklist to all their approved plans. So whatever inspector goes on site, be it a building inspector or fire inspector, they see that checklist, and they are supposed to keep in mind all those factors every time they go out there and inspect. I think that is a really proactive way of dealing with it. Then you have a model fire safety plan. This would be for the builder, the developer who says, I've never had to do this anywhere else. I don't even know where to start. I don't have the money to hire a fire protection engineer. So you print out the model, you do an electronic version of the model fire safety plan, and you send it to that person. It's in Word, so they can manipulate it. They can do it to tailor their own personal needs, and it covers every single aspect that they need to cover in a good fire safety plan. We have a hot work checklist, a model fire watch policy. We have standards for construction site safety, fire policy, a code of safe practices acknowledgement. That would be for your employees that you train, hopefully you train, that they sign this and it's kept in their personnel file, and they receive the training and they sign that they are to follow all these safe practices that they have learned about in the training. This is in a perfect world. We have an outline for evacuation planning, which I know a lot of jurisdictions require an evacuation plan on construction sites. I don't know a lot require a total fire safety plan. So I can just scroll down, and here is your 241 checklist. It covers program manager, temporary offices and sheds, smoking, everything that we talked about last week in the construction fire safety best practices. And then you have a model fire safety plan. And I even highlighted the code sections, so you can delete out whatever code you don't use. And yeah, we talk about access and parking here. And this is, like I said, once again, this is generated by the builder, developer, whoever is responsible for construction site safety that is on the builder side of it. As you can see, it's pretty comprehensive. Then we have a hot work checklist, and this would be a self-audit. So your program manager who would issue the internal hot work permit would go through and inspect pre and post hot work, and they would use this as the criteria for whether their hot work program is good. We have a fire watch policy. I know that I am on eParade, which is a fire department listserv, and every so often I'll see people ask for model fire watch policies. So when they get put up there, I try to grab some, look at those, and pull out the better ones. As you see at the top header, your fire department logo here, and then your fire department address here. Standards for construction site fire policy, and this would just be a sample internal policy. So if you, this really has the templates for any document you would possibly need in a construction fire safety program. And like I said, they all can be manipulated and used for your benefits. This is a code of safe practices acknowledgement that the employee would sign and give back to the employer for his personnel file. And last but not least, the outline for evacuation planning. I'll have everything you should have in your evacuation plan. So come visit, join. We have a companion Facebook page as well. So if you want to ask questions in real time, or I am always grateful when people send me sample documents. If you have documents, a fire safety plan, any ones that I want to talk about, maybe ones that I haven't thought of to put on there, please send them to me. If you are giving any kind of construction fire safety training, let me know. We have a section on upcoming events. We can promote it both on this page and on the Facebook page. If you have pictures, we're going to add a section for public domain pictures, where if you're doing a construction fire safety presentation and you're looking for pictures to spruce your slides up, you can go and get our public domain pictures. But we don't quite have all those ready to roll yet, but that's coming soon.
Excellent, Ray. Thanks for sharing that. So I'll take a few of these questions in the order they came in. There were several questions about cooking equipment and how that's causing fires. I think there's the impression that maybe we're talking about cooking equipment like you would see in an occupied structure, but we're talking about temporary cooking equipment. Can you elaborate on that and talk about some scenarios where that's happening?
Yes. I could only speak the direct knowledge that I have with it in the jurisdictions that I've worked in. There is a transient population of subcontractors, and some of these folks, we've actually had problems with them actually coming back after hours and living in some of these construction sites. And even when they don't do that, to save money, bring and cook on sites. And we're not talking about equipment that is meant to be in the building. We're talking about hot plates or even hibachis or sort of camp stoves, the Coleman propane stoves. Those are the ones that are starting these fires. I know that bigger construction sites that I've been on that really take safety seriously, they usually have a designated cooking area outside the structure, away from the principal structure, and in that they'll have microwaves only, and that's the only place you're allowed to eat. And there's another benefit to that it cuts down on trash and debris. If they can eat anywhere in the building that they want, then you have the waste, the bags, the containers, and they don't have trash cans every floor. So sometimes they take this trash and they throw it down a chute or throw it down a void in construction. And these are also the places that when people are smoking illegally in these places, they throw their cigarette butts because they don't want to be discovered by leaving them on the ground. And there you have an ignition source, and you have a a fuel source. And that would be in a void space, which would be the worst place in the world for a construction fire to start, or any fire to start.
Yeah, kind of a perfect storm, huh?
Yes.
So there's a clarification here about the collapse zone. Were the guidelines reduced from 2.5 to 2 times the building height? Was 2.5 ever part of the guidelines?
I've only seen 2 times the height, but if somebody has more recent information, please send it forward to me. Obviously, 2.5 times would be better than 2 times, but
Okay.
the tactics books that I've read, and these aren't codes, these are books of fire department tactics I've read have always been 2 times. But like I said, if the latest information now is 2.5 times, I would, the farther the better, but I would like to get a source on that.
And that could be a regional thing too, right? That could be.
Absolutely. I mean, every fire department has their own internal standard operating procedure.
Okay. Can you share an example of a cold weather safety plan? Or do you have any experience with that?
Well, a cold weather safety plan would involve heater safety, absolutely no open burning. This occurs a lot, these burn barrels on sites, especially with demolition projects where they are actually trying to burn the demoed materials so they have less to haul away. They should be prohibited in their entirety. And if you need a place for workers to warm up, then you need to have approved heaters, temporary heaters, and they need to be attended while they're being used, and they have to be installed properly, far enough with the proper clearances around, about 36 inches around in every direction, and they are placed where they won't easily get knocked over.
Okay, good. So one of the slides showed what appeared to be some moisture-resistant gypsum installed between units during construction. Is that showing up on some of these multifamily construction sites? I'm not aware that that's a requirement per the code, but is that something builders are doing to try and mitigate?
It's not a code requirement as of yet in the model codes. However, places like LA, I know places like the Bay Area are kicking around their construction fire safety policies that will be enforced like code, to where you need to start compartmentalizing these structures. So if you have a fire partition or fire barrier, that needs to go up with the building, and it needs to be buttoned up. So that means if you have a 20-minute door that's supposed to be in there, you need to have a 20-minute door in there, or a 90-minute door, or an equivalent to that if you don't want to put a brand new door in there during construction. So protecting and cladding the building inside and out as it goes up are starting to be requirements. And in Canada, they are doing that. They are, in certain parts anyway, you have to, if you have a combustible construction, you have to clad it with non-combustible coverings as it goes up. Usually, if you want to be really strict, it would be 2 floors below the highest floor, but I think more reasonably 4 floors below the highest floor.
And that's pretty consistent with what we're seeing coming with some of the tall mass timber code changes too, right?
It's coming with those code changes, but as I said, some jurisdictions saw that and like it so much they're applying it to other types of construction because it would be effective.
Interesting. All right, so the last one, some folks really like the resources that you showed on the construction fire safety website. Is that exclusively for fire service folks, or who is that designed for?
It's designed for fire service folks. It's designed for builders, designers, basically anybody, building officials, anybody who touches construction. You'll come at it from a different point of view, but it has, like I said, the fire safety plans there. It also has a section on best practices, and I just pulled up. It will show up on your screen right now. Best practices when it comes to electrical safety, housekeeping on construction site, power operated motorized equipment. I talked about the phase occupancy. So there's some redundancy, but cutting and welding. So if you were a safety officer on a construction site hired by the company, or you had any responsibilities on site with safety, you would want to come pull these documents up and use these to inform your internal plan and your internal training with your employees on site.
Great. Well, Ray, that's about all the questions and really about all the time we've got. Any closing remarks before Marcy comes back to kind of close us out on some housekeeping things?
I want to thank everybody for their attention. Last time I had some great input, and some people contacted me and sent me some documents that they thought that should be on the site, and I put them on there and I reviewed them, and I would invite people to send me that, send me their pictures of training, or if they have any, they see any blatant violations, take a picture and send to me. I'd like to get a collection of sort of bad actors out there to really illustrate some of the really bad practices that are going on out there, and hopefully clean those up.